let's develop a theory for arc length. The motivating question for this is this one. How far is it to Modesto? Notice I'm not capitalizing Modesto. 50 miles? You all really answered in miles.
Because we drive.
No, people who drive answer in minutes. It's really hoping for minutes.
Yeah, but it all depends how fast you're going, so it doesn't matter.
Yeah, I mean,
Okay.
it's Modesto one time in 35 minutes.
I think I've done it 15, but that's beside the point.
Yeah. Got places to be.
Don't need to worry about splitting lines.
These guys do the highway.
Okay. So, let's try this. The fundamental thing I want to get to here is, how do you translate distance and time, and why do people feel like they're usually interchangeable when they're driving? Right? So I want to develop a theory for arc length, right? Arc length is this thing about distance. Yeah? Okay, so I want to think about distance, but I don't have a distance function, right? At my disposal, I have probably a position function, a velocity function, and an acceleration function. Yeah? And assume I have some parameterized path to Modesto, right? Which role is that going to be? It's my path to Modesto. Is that going to be a position, a velocity, or an acceleration? Yeah, it's going to be a position, right? So I'm going to stick Modesto kind of into my position function. Get some parameterization for that. Get some windy little path. Now I want to know how far it is, right? So how do I figure out how far it is? How about if you drove 60 miles an hour, how long would it take you to get there?
Well, how are you getting there? Are you straight or are you turning?
Well, you guys drive there, right?
Yeah.
You drive along this winding little path.
A mile a minute.
Probably on average an hour.
Yeah, it'd take you maybe an hour if you drove 60.
Yeah.
That means it's about 60 miles, right?
So T to Modesto is 6.
Yeah. Right? So how did we figure that out? Like, how could I kind of generalize this process? Am I using a velocity function? What am I using? What's that 60 miles an hour?
That's a velocity function.
It's part of the velocity.
60 minus or
Easier.
I think on the actual position.
Yeah, it's the magnitude of the velocity function, right? So if I thought about distance, right, I might think, okay, distance is more or less time times speed. Right? So my idea would be to say, okay, so the change in distance is probably time times
Change in speed.
absolute value of speed,
Magnitude of speed.
magnitude of speed. Does that kind of make sense? I really should put it change in time. You guys see that?
Yeah.
That idea is like, okay, I'm driving along. Right, there's a here. Over here's a Modesto. And there's some kind of funky path that gets me there, right? I don't really care which direction the velocity vector is pointing, right? I just care how long it is. It's like, say, in this little bit, you know, up here in the mountains, there's not much traffic. I get to drive 60. Then I hit Knight's Ferry and every jerk in the world's on the road, right? And from there till, I don't know, Riverside or whatever's down there, right?
Riverside.
Whatever that little town is, right? Driving down there, and things are okay, right? It's like 40 miles per hour for a while.
Unless it's Memorial Day weekend.
Yeah.
And then it's
And then definitely after I hit River Bank,
Yeah.
Okay.
Why
After I
don't
hit
you
river
go to-
bank, things really slow the heck down.
That's
Right.
why you bypass it and skip over Oaktown.
Okay. Regardless of how the best way to get to Modesto.
Pop out right by Discoun's factories and you're there in 45 minutes.
And in and out is really close.
Okay. So if I wanted to figure out how far it was, right? I could look at my rate and then multiply by how long I was traveling at that rate, right? So here's your V's, right? You have several different V primes. You'd multiply by how long you were going that. Then you'd get how far was the bit that I traveled at 60, how far was the bit that I traveled at 40, and how far was the bit that I traveled at 30. You guys see that? So if I wanted to set this up exactly, how would I do that? I want to say arc length.
So take the limit as t goes to 0 of the sum of the little arcs.
Okay, perfect. Take the limit as the sum. Take the limit as the piece size goes to 0, the sum of the little pieces, or write it the calc way, which is
The interval.
okay. So I want to integrate.
Thought we were building it from the bottom up.
We are right, but you guys know how to do Riemann sums now. We've done those several times now.
Yeah.
Okay, so I got the integral from a to b of what? What am I going to integrate?
The speed.
Yeah, the speed, the magnitude of the velocity vector. D time, right? Okay, now there's one little assumption with this thing.
No sharp changes or something.
Close.
It's constant.
Velocity.
No, velocity doesn't need to be constant, but it does need to be positive. It would be really stupid, for instance, if you drove backwards, right?
Yeah.
Like, will it add miles to your odometer? Sure. Are they in the right direction?
No.
No, definitely not, right? So, really here, assuming that v of t,
It's greater than 0.
well,
Taking the magnitude.
this is weird, right? I'm taking the magnitude of it. The thing I'm integrating is always going to be positive. You guys see that? So, what do I want to say?
Square root of t squared.
That won't do it either. Really, I want to say I'm not going backwards, right?
That's right.
Maybe let me just say, assuming that p of t, right?
Oh, is it constant? Because then it would just, the derivative would just be 0.
Oh, what if I said that? What if I said v of t is never the 0 vector?
Okay.
Yeah, if it's continuous.
Yeah, okay.
And v of t is continuous.
And you can turn around without making a jump.
Perfect. Right? You guys see that? I can't get going backwards if I never stop and I'm a continuous velocity, right? You guys see that? Okay. The intermediate value theorem says you can't find a way, thankfully. Cool? You guys see this? So this is essentially no backtracking, right? It should be noted that this is the arc length of the path you're following, right? Not necessarily the best path. So when I said we went through Riverbank and you guys were all like, bypass it, right? That's a different path. You guys see that?
Yeah.
Cool.